All right, I'd like to call the August meeting of the Homebrew Robotics Club to order. This evening, we have a special presentation by one of our own, Pito Salas. He's been active on the mailing list for a few years now, discussing ROS navigation and other subjects. He teaches hands-on computing at Brandeis University in Waltham, Boston, Massachusetts. Did I say that right,
Yep.
Pito? Okay.
Yep.
You've been teaching there, I believe, for 12 years, course in robotics, software engineering, operating systems, and software entrepreneurship. What was that Lotus program you made, the three-dimensional spreadsheet?
Improv.
Improv? Yeah, I used to sell we sold Next computers. Actually familiar with a product you were
unbelievable. I actually found somebody who sold one.
One story, and I'll be brief. At the Computer Attic, we were the only Next retailer, and Steve Jobs would periodically come rollerblading through. It wasn't that big of a deal, but we had a display set up of Lotus Improv, and Jobs came in and he was like, "Excellent software." He came in, he started picking up all these boxes, and they were all empty.
Well, I actually have one.
Anyways,
enjoy for old time's sake.
There you go. No, but I was like, it was pretty funny actually. But all right, so moving on along. Before we get started here, let's start off with industry news. Is there any industry news out there? Anybody'd like to share? Let's see. Oh, Unitree. Unitree's got their humanoid robot out now for $16,000. I'll put a link in the chat here. And I guess I'll just share my screen real quick. Yeah, this one's gotten a lot of press lately. They had a $16,000 dog out, I think, that was being chatted about for quite a while. But now they've got the humanoid robot. Seems to be an awful lot going on in humanoid robots now between Boston and what's Boston Dynamics robot's name? Atlas and Optimus from Tesla. So there's some real action now in the humanoid robot side. Any other industry news this evening? That was a good presentation we had from NVIDIA last month. I think there was some news about them in the stock today. What did they do? Anyways, they're doing crazy numbers, and they're still doing. I think their profits like doubled this year. So AI keeps rolling on. Is there any other industry news out there anybody'd like to bring up or talk about?
Well, yeah, the World Robot Conference in Beijing went off last week, and there's lots of videos online for that.
Can you post a link for that?
I'll do that.
Let's see, Carl Sutter's posted here.
I don't know much about it, but it's the
that's Atlas.
The electric
that's
Atlas.
The Boston Dynamics. Yeah,
just doing push-ups here.
Yeah, I don't see the electric Atlas doing everything that the hydraulic one did yet, but we'll see. It's all very interesting. All right.
Said they claimed it was stronger. The electric was stronger than the hydraulic now.
Yeah, but it's not doing what do they call it? The athletic running and jumping, the parlays or whatever they call it. I don't see it doing backflips yet, but anyways, we'll see. Not that that's useful for anything other than entertainment.
I also think those videos are heavily choreographed and man behind the curtain. I'm not so sure that actually an Atlas would do that in real life.
Would love to see the blooper reel, huh?
Yeah, exactly. Yeah.
All right. Moving on from industry news, how about club news? We got any club news to go over this this evening. Ralph, do you want to talk about the Botnik?
Yeah, sure. I can let me talk about that real quick, and then I think you got something you want to talk about too. Just yeah. Anyway, the Botnik's on September, what is it, 22nd, and
Yeah.
it's a Sunday, and it's at Baylands in Sunnyvale. So there's been some emails about it in the alias, so look for that. But should be a lot of fun. Good way to get out of the house once in a while, get your robot some sunshine and some exercise. Do a practice Robot Magellan event. So anyway, that's what the Botnik's going to be about primarily.
Robo
Mark, go
Magellan's.
Yeah, so we were accepted to the Bay Area Maker Fair again in October 19th, I believe, something around there. There's only one weekend, so let me know who wants to be part of it. And I'm also looking for interesting pictures of the group to make the basically the group page interesting for people to check out.
And where's it going to be? Same place, Vallejo or whatever?
Yeah, Vallejo, Mare Island thingy. So Rafael says something about robo business in Santa Clara, a conference, I believe. Santa Clara Convention Center. So, yeah.
What are we talking about?
Trade show.
Trade show. Robot business. Trade show.
Oh, Robo Business.
Yeah.
Okay, I put a link in the chat for the Maker Fair, and that's October the 18th through the 20th, historic Mare Island. And we'll have Botnik, which is a Robo Magellan event in Sunnyvale. What's that, Bayland Park?
Yes.
Yeah.
Ralph, it's Bayland Park, and there'll be a table there. So bring not just the Robo Magellan robots, but bring your robots in general, so you can show off your robots and talk about them and stuff like that. But the main thing's the Robo Magellan. So also next month is our challenge month, phase 3. So you have a presentation to give. I'll be bugging you all month long. I'm really talking to myself when I do this, but everybody's responsible for showing, we're a builders club. When you come to the Homebrew Robotics Club, we're not just the talk about robots club, we're a builders club. So you're expected to be building something, and building something, you should either have something to demo or talk about, or be asking questions and getting answers. And this is really a great group to work with for that kind of thing. Any other club news this evening? All right, let's get into I need help with. Is there anything anybody needs specific help with in building their robot? Or maybe a particular accomplishment? We're going to get to show and tell in a bit here, but I mean, if you crossed a major hurdle or something.
Well, I've been looking for some glue to glue to polyethylene flask. Is there such a thing?
Who is this, Stephen?
Yes.
What's the question?
Is there any kind of glue that actually works on polyethylene plastic?
Have you tried like E6000?
Yes.
It doesn't adhere to polyethylene plastic?
Nope. Well, it only kind of does.
Okay, I know it takes a long time to cure, but man, that stuff sticks to everything.
Yeah, well, I tried to go from, we'll say, a wooden dowel to a piece of polyethylene plastic, and that ain't happening. Then I tried to glue, what the hell else? Something else with polyethylene, a box. I'm just gluing two pieces together, and didn't work either. And that's after 4 days at 100-degree weather.
Okay, I mean, I'm basically in between E6000 as a sealant, which takes 24 hours to cure, and Bob Smith's 5-minute epoxy, which I recommend if you're in a hurry. It actually takes 10 minutes to cure, but that's good stuff. Post your question on the mailing list and let's see what kind of response you get, okay?
All right, thanks.
All right, what I need help with. Anybody else need anything help with anything in particular, robot-wise? Going once, going twice. Let's get into show and tell now. Who's got a show and tell? Not everybody at once. Oh, I do. Let me share my screen real quick. This is Smarty 2, one of the smart tables. I've got a little map here, and I'm going to navigate into the kitchen. We've basically taken the Lino robot program, which has a URDF, a Universal Robot Description format that's like a 10-inch square base with 3-inch wheels. And what I've done is I've made it into the mock turtlebot, which is a Roomba base and a little tabletop. I've got a DL06 LiDAR on there, and the camera's Logitech C270. This is built off the Create 3. I really like the Create 3 from iRobot. One of the really cool features on it, and I'm going to navigate back into the lounge here, is that it's got some features including dock and undock, so I can navigate within the vicinity of a docking base and just run a docking action, and the robot will autonomously dock. Same thing with undocking. It's also got like wall following and stuff like that built in. The bumpers actually have a reflex, so if I'm navigating and I bump into something with the left bumper, it automatically backs up, turns left, and goes forward. So we're building these mock turtle bots, Alan, Ross, Thomas, and Phil and I, and we're making them like 28 different ways. So here's the robot coming into the lounge now. And so we'll have it with like 3 different bases, the Create 3, the bot vac, which is arguably the best value, and just a plain Roomba, and then we'll have like 3 different lidars: DL06 RP lidar, XV lidar, and 3 different cameras: PyCam, OAK-D, and kind of mix and match the parts and put together the mock turtle bot that way. So shoot.
So this is a Create 2 sort of experimental thing from iRobot. How does Ross fit into that?
This is the Create 3.
Okay.
The Create 3 is the latest iteration. It's basically made from refurbished i3s. What they've done when you boot up the Create 3 is it launches several nodes, including command velocity and so on. That's a topic, of course. But it runs these nodes so that out of the box you can run teleop keyboard and drive it around, for example. But what I've observed is the suspension is especially good. We put Superstruct little tabletops on the BotVac and the Create, and as much as I hate to say it, the Create 3 suspension is superior. When I put the tabletop on the BotVac, it cannot make the hard floor to carpet transition, but the Create 3 makes it going away. Plus, it's got things built in, including the docking action and the undocking action and the wall following. The bumpers have reflectors built into them, so it's worth the $350. You got to add $100 for a lidar, whereas the BotVac is arguably the best value because you can get them from eBay for like $100 refurbished, and it includes the lidar. So,
I won like a Create something like 3 years ago.
Sure, that was just it's made from refurbished Roombas. This is why they can't sell them in Europe. They're not RoHS compliant.
So the older ones didn't run ROS, right? This is a new
True,
thing?
they did not. They had their own proprietary protocol.
Okay.
Yeah. Although the original TurtleBot was made with a Create, and this is what we're using to do the Roomba version. Again, we're making the mock bot, the mock turtle bot. Okay, like mock turtle soup. Okay, in Alice in Wonderland. Okay, the mock bot, you can use, it's all about the base. You can use a Create 3, you can use a bot vac, or you can use a regular Roomba. If you pop the lid on a regular Roomba, it's got like a 7-pin mini DIN you can plug in, and there's code out there to make it into like, well, you'll be able to drive it around and interface with it with ROS. But it's not as complete. It's not as complete as a Create 3, huh?
A regular Roomba does not have ROS. It just has the pin.
Oh, no, not at all. Although I will say we had the VP of engineering do a presentation here. I think it was 2 years ago, and he got hired because of his ROS experience. They use a lot of ROS in their simulation and so forth.
Sure, I believe it. I believe
At iRobot, yeah.
Yeah, I believe it. Yeah.
Okay. Any other? Mike, Mr. Mike, did you want to talk about Saigon?
No, the audio here is not going to work.
Anybody else have a show and tell?
I have a audio thing I'm working on for uses basic technology that we would use in mobile robotics. I can demo that real quick.
Okay, go ahead, Steve.
That background is really disconcerting, I gotta say.
See if I can get on the screen here. Where did I go? Okay, so I made this box as part of my costume for an event that's coming up on Saturday night. That's, we'll call it Star Wars related. So this is like the chest box that they would wear as a fighter pilot on an X-Wing. Sort of. But since most of the ones that people make don't do anything, I had to add some functionality. So I gave it some sounds. It uses an Arduino, an MP3 player, and some buttons.
How did we get into this mess? We seem to be made to suffer. It's our lot in life. I've got to rest before I fall apart. My joints are almost frozen. What a desolate place this is. It's much too rocky. I've just about had enough of you. Be malfunctioning within a day, you nearsighted scrap pile.
Yeah, it's all kind of, there's 177 sound effects in it right now. But I'm going as the character Porkins, which is a fighter pilot that was a really fat guy. In fact, if I'm not in the video, you can see another prop that I made that's a bucket of it's got support that's deep fried using Kentucky Fried Chicken bucket. It also has the same kind of sound effects in it. And of course, for fun, I have other buttons that do other things like burp. And
wait a minute. He kind of looks like a baby. Come here, I'm gonna eat you. I'm bigger than you. I'm higher in the food chain. Get in my belly. Come on. You're lucky, wee man.
so they got like Fat Bastard, and I got the Family Guy, and there's all kinds of, we'll call them comical things, because my version of Porkins is an eater. That's just one of his main functions. And building the rest of his costume. Like they have little pockets with tools and stuff in them. Well, mine has a fork, knife, and a spoon. All along that idea for the Porkins costume, anyways. So he has a bucket of Kashyyyk fried boards. I don't have that out here. It's got Chewbacca on it instead of Colonel Sanders.
Thank you very
The
much.
board was totally animated and moved and flopped around, and I burned it up on Sunday. I burnt the motor up in it, so it won't be animated.
One step over the
Probably
line.
it will be for the Maker Faire, but not this version because I got to buy a whole new one.
All right. What else? Any other show and tell out there? Is there one local?
I have one.
Hey, Tony.
Yeah.
You want to do it back here up
Yeah,
front?
let's just do it here. This will be easier. So this is just a new base I bought on Amazon for $33 plus tax. So if anyone wants a little Mecanum base about that big, they're out there. I've powered it up. I've tested it. I'm working on getting my high control loop stuff all connected and doing all the wiring. Had a fun weekend with things like my voltmeters are all broken and stuff like that. So this when you happens when you don't do higher robotics for a while, but you gotta get back in the swing of things. So anyway, I just thought I'd show this so people can buy it.
You got 4 weeks, Tony. You got
And
4
we'll see.
weeks. We got 4 weeks. We're going to do the TableBot challenge, right?
You have a long weekend in there, so.
Yes.
I challenge you.
No, it's some new gearbox standard thing called TT motor. Can I put this on the board? Yeah, you totally can do whatever you want. Just don't break it, otherwise you have to find a new one.
TP motor,
TT,
TT motor.
T is in tango, T is in tango, space motor. And it's, yeah, they're out there and it's pretty not super powerful in terms of motors. I think it'll exert maybe, I don't know, we'll find out. I'll get a force meter and tell you how powerful it is at the end of the day. But they're out there and you get 4-wheel drive really easily with this stuff.
Looking forward, Tony, looking forward. All right. What else? Any more show and tell this evening? Going once, going twice. All right. Well, let's move into why we came here. I'd like to introduce our speaker, Pito Salas. Peter, again, has been teaching at the Brandeis University in Massachusetts, and he teaches robotics. And Peter, why don't you go ahead and take the show? Thank you very much.
Okay. Let me share my screen and get things going here. Right. So I actually made some notes, and I'll give you guys the URL so you can follow it if you want. Here it is. Even got your logo in there. I'll put it in the chat. Okay, so not knowing exactly what people were interested in, I of course wrote down a lot more than we will have time for. I hope that everybody just interrupt me with questions when you have them. Act like you're sleepy if I'm spending too much time on something, and I'll try to pace it. We'll see how far I get. Essentially, what I wanted to talk about a little bit is Brandeis as a computer science, Brandeis University and its computer science program, how I got there, what my background is, and what it was like to create this course and what it's like to teach this course. So very much, I mean, I was going down memory lane writing this stuff down. Maybe this will be better this way. We'll see. If you click on the link I sent you, that actually is the website for the course. And I just added the page because this was the most convenient way for me to create a really quick presentation. So there'll be typos, etc. I'm sure. But basically, thanks very much for inviting me. Thanks very much for being so helpful over all the questions I've thrown your way. It's been a really wonderful community, friendly folks that know a lot. So it's been really, really great. And I appreciate it, given that I'm so far away and I just sort of like Googled my way into this club. But I just did order my t-shirt. So I'm going to be able to wear it next time and sport it. I had to pick the color. It was kind of hard. Okay. So my background, computer science, undergraduate from Brandeis by coincidence. I actually was pre-med before when I went to college, but when you're 17, you don't know anything. And when I came, this is a really quick side note, but I was born and grew up in an island in the Caribbean called Curacao. Anybody ever heard of Curacao? That's where I'm from. Come on, somebody must have. Aruba, I bet there's people that know about Aruba.
Aruba
Is our famous sibling. We resent Aruba because Curacao is much better. But anyway, that's where I'm from, and I came here. It was in the 70s. I was 17, and I literally had never seen a computer in my life. So I walked by the computer center, big glass room, as you know, with the PDP-10 inside, and I went like, this is crazy. And I went back to my organic chemistry class. But by junior year, I was a computer science major. And it it was really easy to get a job. It wasn't like now where it's super competitive and there's all these complicated hurdles people have to go through. But I worked, like I think some of you worked at DEC back then. That was my first job. I worked at a long forgotten company, which had a really good enterprise database system before it was relational. Then I worked at Lotus Development. If one of you old Mac heads might remember a product called Jazz that came before Improv. I worked on that. I was one of the developers on that. I worked on Improv, which was a multidimensional spreadsheet product, it is a long story. But anyway, I won't go into it. But it's a really, really cool product. And in a way, looking back on what I've done, it's one of the things I'm most proud of, honestly. I worked on Lotus Notes, and then I started a company called eRoom Technology. Also now, of course, lost into the dustbins of history because that was in the late 90s. But that was cool. We started the company and we ended up selling it to Documentum. And then I decided I didn't want to work at a company anymore. I became a consultant for about 10 years. And then I got tired of that and I thought, hey, you know what? I can be a professor. I thought that might be an easy thing to do, right? It should be fun, easy hours. It turns out that, I was a software engineer, and I was not an academic. Since then, I'm kind of a pretend academic. I've written some papers, got them published, presented at conferences, but basically I'm still an applied computer science guy. In my career, I passed up or turned down many opportunities to go into, and I'm sure among the people that are here, this story is probably very familiar, where you get to a point in your career and people are going like, you can't be a programmer anymore. You got to be management, you got to be marketing, whatever. But I never did that. I was stuck in the technical side. But again, I think some of you might know when you get older, your skills change. Your eyesight certainly changed. Your retention of lots of difficult APIs change and all that. But other things get better. Experience gets better and it's very useful. And it gets to be fun to take all the stuff you've amassed in your brain over all these years and do something different with it. So around 2010, I was done with consulting. I always... by the way, if you remember 2008, there was a bit of a problem in the economy then, and somehow my rates just went down the drain. So, but I had all this stuff I'd learned. I mean, I still loved hacking. I still love programming. I still love messing around with computers. It's totally my hobby, in addition to being my profession. So, I said, hey, let's be a professor. How hard can it be? Well, it turns out to be hard. The organism of academia is very protective of its own, and it's very hard to break through that barrier. I didn't have a PhD. I was in my 50s. Not a slam dunk. I thought it would be. I thought like, hey, they're gonna love what I got to teach. I created some sample curricula, which, by the way, in academia, we don't say, normal people say curriculums, but we have to say curricula. And created ideas for courses. Didn't know how you design a course, really. What does it take? What is that all about? And I'll tell you more about that in a few minutes. But I developed a few ideas, leveraging heavily the experience I thought I had to offer. With compared to what was available at East University. I talked to Brandeis, I talked to Boston University, I talked to Olin College. Anybody ever hear of Olin College, by the way? No. You've probably heard of Harvey Mudd, right?
Yeah.
Olin College is just like Harvey Mudd, same cool kind of culture and mentality, but it's in Massachusetts, an engineering undergrad college. I taught there for a year. And then I came back to Brandeis. They had a summer program. They needed somebody to co-teach, and I agreed to do it for, I rounded down to $0. It was pretty close to $0. But the students liked what I had to offer, and they needed more of that stuff, which was my first offering there was actually a software engineering course. I was able to become I put the quotes around professor of the practice. That's what they call it if you're not tenure track. That's the job offer I got. And yes, it is my alma mater, but it was not particularly a deciding factor either of them hiring me or my going there. It just happened to be the one from whom I was able to get a job. But there's definitely an element of nostalgia being back there, although now I'm used to it 10 years into it. But Brandeis is traditionally a liberal arts college. And so when I went to Brandeis in the 70s, there was no business school, there was no pre-law, there was no software engineering, computer engineering, there was no accounting. All these applied things did not exist. In fact, it was kind of an allergic reaction if you brought up, let's teach that, because it's like, oh, that's useful. Why would anybody want to teach that in university? But that's changed a lot. It changed when, as evidenced by the fact that they were willing to hire me and let me do my thing. But it's also changed beyond that. I mean, there's a really good business school now. There's obviously a very large kind of life sciences departments of all kinds that are, very well known. They win Nobel Prizes, et cetera. And I actually was, when I was an undergraduate, one of the very first computer science graduates at Brandeis, 76. By the way, it's the only department I've ever worked in, only academia I've ever been in, so my perspective is very limited. I can't say anything in general about what academia is like. I just know what it's like for me at Brandeis. So we have a relatively small department, about 15 faculty, computer science faculty of all levels. Tenured faculty, tenure track faculty, non-tenure, et cetera. And we have about 300 to 400 computer science majors at any moment. So if you look at all classes and master's students as well. So it's not tiny, but it's certainly not big. Traditionally, I mean, when I went and in the following 10, 20 years, it was much more theoretically focused, research focused, theory, how many angels can dance on the head of a pin kind of stuff. But still, I mean, I would say that all along there was programming involved. It wasn't just all writing. It wasn't all mathematics or whatever. But lately it's become much more open, and students demand this, and students' parents that pay the bills demand this. That there'll be more offerings that are, applied computer science, let's say. But I don't know, some of you, I think, are professors or have been, and you probably know that college students are really, really young. You got to really go to the ABC to teach them to go from high school as a freshman or a sophomore. So yes, we're teaching applied computer science, but a lot of it is what we would consider pretty elementary. Now, it's interesting though, because I'm not here to poo-poo theory, because all that we do in applied computer science, robotics, software engineering, it rests on the theoretical work, and it does rely on it. And interestingly, not only that, but students that are interviewing for jobs have to bone up on their fundamental computer science theory, because that does come up, depending on where you interview, of course. It does come up. But anyway, there's more of an applied aspect, and I'm one of the people, and obviously that's what I care about. So for Brandeis, let me just, and you can click on this yourself, but I'm not going to go through this, but there's a fair number of courses just being offered this semester. You can look at what they are. It covers sort of the basics of computer science, algorithms, data structures, databases, operating systems, fundamental computer science theory. All those, there are courses for all those. And then at the next level, the university or the department does have a very good reputation in AI and machine learning, neural nets, computational linguistics. I mean, there's a lot of grants, a lot of research output in that area. It's very well regarded. And even though there's a typo right there, even though you know, this is a fair bit of it is theory, if you look at the actual work that students do and the actual assignments and the actual content in the lectures, there's plenty of actual difficult programming. But you know, when students do a programming assignment, whether it's in Python or Java or Go or whatever, it's still just a programming assignment, and it's a moment in time. They write what I would call, you know, disposable or write-only code, because they never need to pick it up again in a year and extend it or improve it. And they tend to be a few pages of code, not maybe 5 or 10, but not 100, not 1,000. So there's still a big gap when somebody comes out of college with a nice computer science degree as to what they actually know on average. I mean, we do get plenty of like super genius types that don't need us at all. You know, they know they move faster and think quicker than we do. But you know, overall, keep in mind that that's kind of what you're building. You're starting from nothing. When I went to college, and again, I'm sure some of you can say, we learned about you know, 2's complement representation of integers, and you know, IEEE floating point. None of that stuff comes up. I mean, that's all like below the surface. And some people bemoan that. They go like, well, you can't really use a computer. I mean, you can say of me, I don't know exactly how you know, circuits and wires and things like that. I just like ask you guys how to plug things together. So there's the stack is too deep, I think. The amount of abstraction one has to learn is just too much to expect or to attempt to teach anybody over a span of a 4-year college career, the whole bit. And so we have to pick where in the stack we teach. And some of the stuff that some of us think are so fundamental and essential for very existence fall off the wayside. So, you know, in that context, oh, and by the way, there was, until my course, there was no course that actually involved hardware. So people were used to getting their Mac, plugging it in and running things, or running it in the cloud or whatnot. But don't ask them about something physical that can break, or you can step on, or you can trip over, or you can shake. So my courses, oh, this is, you know, this is a little flaw here. So excuse me, I'm going to go to the vanilla version of this page. It's the same thing in text. I just want to show you this and make it bigger. So basically my courses are, and it varies by semester. Here's a problem here, but anyway. I teach a course called, by the way, tomorrow is the first day of classes. So you got me at a really like keyed up moment here, because I've been spending the whole day dealing with the content, emailing students, getting the course management system to do what I wanted to do. And tomorrow at 4 o'clock, you're all invited to my first classes, because they're all Zoomed. They're all recorded. Anyway, software entrepreneurship, I'm teaching this semester. It's a course in, you know, I would say customer discovery and sort of basic business strategy for software, for technology. Autonomous robotics, my favorite between us, which I'm teaching also this semester. I teach 4 courses per year, by the way, 2 and 2, which is typical. And then the other courses I've taught are software engineering capstone, where we build a full stack application, deploy it to the cloud, test it, scale it, etc. And then I have a course called Software Engineering for Scalability, which is all about scaling to millions of users. Those are all electives. And when you teach an elective, you have to sell it, because if you don't have a minimum of, let's say, 8 or 9 students, they cancel it, or you won't even get to teach it, right? So we do have to, not only define it and describe it, but, give a little bit of marketing and so on. Required courses are easier. They have to take them, so they show up, and the classes can be very, very large. So the required courses I've taught in the past, not this year, are one of the very first programming courses students take as a freshman, or at least the first semester of computer science in Java programming. It's got a more confusing name, but that's basically Introduction to Java Programming. And then operating systems, which is a really wonderful course to teach. It's really fascinating. It's considered one of the most difficult courses in the university, and it's required. I'll take a breather here and see if anybody wants to ask a question or make a comment. Okay.
Yeah, let's see. I was a professor and then I moved into supporting computers. And I remember this is in 85. And I remember computer science was just coming in. So most of the computer science people were either from engineering and the hardware side or for the mathematics side. And at my university, the mathematics side won. So what they taught was Pascal and Ada. They were real practical things to send the students out into the world with. Meanwhile, the engineers are saying, hey, we need to teach C and Linux.
Right, right.
So now I bet it's probably straightened out a little bit now, but still the the mathematics side is, oh, we want to teach structures and structures.
Yeah.
And then the people go out and they have no practical stuff.
Right.
And the way they hire programmers is, oh, can you explain, name all 7 layers of the application model, where what they need to know is how do you connect something to the internet? What's
so I was there at the beginning of the department at Brandeis, and it came kind of not out of engineering, because as I mentioned before, we had nothing that even smelled like engineering. It came out of mathematics and physics, interestingly enough. And so the first computer science professors were physics and mathematics professors. I did learn Pascal, and I learned Algol, lovely languages back in the day. And my first job, I had to learn assembly language. I remember it on a VAX. That was my first job out of college. So on the job training, etc. But that tension still exists to some extent. I mean, I think people they're not teaching Ada anymore, but they are teaching Java and now Python, and there's a little bit of creative tension among the faculty as to why Java. But Java is a super respectable language. There's no complaints about that. But among the crowd of academics, it's definitely most of them, except if they teach it, they know Python more. But I think if you look across universities, I think there are definitely those, maybe with a more engineering orientation, that focus more on C and C++ and languages like that. And remember, we have a very small department, right? So we can't teach a full suite of C and C++ into the programming and a full suite of Java. We don't have the students, nor do we have the faculty. So you have to make a choice. And one thing that people don't necessarily think about if they're not trying to create courses is that once you have a course that's all built around a certain language, it is very expensive to translate. There's just a lot of moving parts between the content, the textbook, the homework assignments, the grading, the rubrics, the instructions. It goes on and on. So you definitely get reluctance of changing languages. Also, some people are lazy to learn something new, right? They go like, well, I know this fine. And sometimes you find people that are teaching stuff that is like, really obsolete because they're just stuck in the mud and they've been, they've gotten so good at teaching this thing and they're really comfortable. And it's really difficult sometimes to switch gears.
Comment?
Yeah.
Ada is being revived a little bit through the Ada Spark formal methods language. I know it's actively being used to try to prove that software is safe. So just a comment.
Yeah. I mean, and the comment is like, really, languages don't die, do they? they're I mean, anybody know I forgot now the language, the IBM language for ball or something. I forgot what it's called. At DEC we have a language called the dot or something like that. Whatever. Anyway, I get off track. But yeah, it's true. So Any other comments? By the way, for some reason, the little green box is supposed to light up around somebody speaking. It's not happening for me, so I can't tell who's speaking. But anyway, if there's no other comments, I'm looking at the screen. I'm going to just plow on. So I teach both undergraduate and graduate students. The courses are defined as available to each type of student, as long as they have the prerequisites. And the interesting thing is that often the undergraduates are actually sharper than the graduates. But certainly there's no clear, like, difference. I mean, when I look out of my class, I have no idea which people in the room are undergraduates or graduates. I treat them the same, the content is the same, and there's no predictive value as to how good a student they're going to be, as far as I can tell. Students know a lot. They are really smart. I mean, they are really sharp. They are very, raw intelligence. They've got it. Energy, creativity, fearlessness. Oh my God, with robots, you see this. They start pulling plugs out. Like, I'm freaking out. Like, don't do that. I want to move the camera. I see them pulling a screwdriver out of the closet. What are you doing? So they're very fearless. And that's a really good thing. I'll show you in a little bit some of the projects that they have undertaken, and they're really difficult projects. But the one thing that's unfortunate is they're very focused on grades. It's just very difficult to get away from that. And you spend a fair amount of time as a teacher thinking about kind of making your material and your presentation and your grading methodology such that you're going to minimize the number of people complaining. And believe it or not, I mean, I was not a student like this, but there are students that will come to you and say, why did I get an 89? And my person sitting right next to me got a 91. Can you explain that? And you want to, like, bite your tongue. So there's too much of a focus on grades for sure. But at the same time, I mean, I have this when I have people come give presentations or talks from industry. You can easily forget that there's a lot of things that we totally take for granted that they have no idea, particularly acronyms, but also simple concepts. And so you do have to really get used to trying to, guess or be empathic to understand what it is that they would know, what has to be defined. But it's all, the general comment on students is it's really a blast. It's really fun. It's really energizing to work with them. It's really fun for me. And one of the things I like best about teaching is designing the course. Thinking about, it's like putting on a play. I mean, you have 13 weeks. I have 2 lectures a week or 2 classes a week. I have 2 labs a week. I gotta know more or less what I'm going to do in each one, even though you change, you improvise, you modify. But if you look at this web page that I'm looking at here, I'm going to just pop out from here, and you might have done it. This is actually the whole course. So you have here my syllabus. If I reduce it a little bit, you'll see that I have here my first lecture, my second lecture. It's all here. So I've worked it out in pretty gory detail. That's just my particular compulsiveness. Not everybody does this. But you do have to look at it as I don't want to call it performance, but it's got a certain beginning, middle, and end. And you've got to hit the mark at the end. At the end, you hope that you will have covered the things that you meant to cover. And you hope that you went at the pace that people could keep up with and not too fast.
Your list of lectures looks awesome.
Yeah. Yeah, it's fun designing. It was really fun designing it. And there's a ton of content in here, a huge amount of content, because I built it up over the years, and I tuned it a little bit all the time. But thanks. So part of my content is down here in course resources is the Homebrew Robotics talk. So we can go back to that. And I just did that because it was the easiest way for me to do it.
So meta.
Pardon?
So meta.
Yeah, very meta. Exactly. Yes, exactly. So a little bit about the classroom. What's the classroom like? Again, at Brandeis, they come in all shapes and sizes, and you don't really have control. You can maybe ask, request, but they're going to give you what they're going to give you, and you have to deal with that. They're all equipped with cameras and projectors and all that, so that's nice. And this is all from COVID. It became like a scramble to get everything upgraded to projection and recording. But I record all my classes because it allows students to go back and look at them if they want to see them again, or if they missed something, or if they literally were not in class. I'm really bad with the blackboard. I don't know how people do it. I have some classrooms that are probably 40 rows deep, like a theater, like a movie theater. And I'm drawing on the blackboard, and I'm sure that half the class can't read what I'm writing. So I don't tend to use that a lot, and I haven't observed enough other people using them, but I don't know how it works. But for me, I'm not happy with that. So what I do is I make these slides, or sometimes I'll even have an old school overhead projector with a piece of paper, and I'll just draw there, and now everybody can see it. And by the way, also you have to think about the people who are watching on Zoom, because if you're on the blackboard, you can really sure that the Zoom camera is not picking it up. You get to decide. Again, remember my particular perspective is limited, but at Brandeis, you get to decide whether you allow laptops or not, whether they can be open or closed, whether you take attendance or not, whether you allow or don't allow or discourage remote attendance. All those things are within your power. And you end up changing it as the semester progresses, where you get the feel for the class. What are they like? How engaged are they? How many people are checked out? Let's be honest, everybody. Some of you right now are checking your email, right? And so you can't escape that. I mean, if you're talking for 50 minutes or 80 minutes or whatever it is your class is, no matter how well you do interactive sections and active learning activities and whatnot, the computer open is going to be a temptation. And I'm the same way, right? I'm the same way. So I don't get too worked up about that, but you do sometimes, very obvious when a student breaks out in a giggle, or their eyes are glazed over, or they're typing very intently. I know you're coding, okay? So, and you get to set those policies, and you have to, work within that scenario. So you're a little bit of an entertainer also. And you're trying to make things interesting, and you have to gauge your audience. If they really get fascinated, like last semester, they said enough with the TFs already. It's like I spent so much time explaining TFs because why? Because I had a hard time understanding them myself. So I, sort of said, I'm going to really go nuts on this. But at the end of it, I was told I spent too much time on it. So you got to listen to your audience and play with that a little bit. Right, and yep, let me just go to the slide mode again, little Baker to look at. Okay. Yeah, and you're often surprisingly the first one to tell them an oldie but goodie joke or war story or dad joke. You go like, you never heard this before? No, I never heard that. It's like amazing. So that's kind of fun also. That's something that we think is so old and so dumb. When is a car not a car? Oh, it's really funny. So that's kind of that's kind of fun. Okay, talked about this, right? So despite the comment about people being distracted, I mean, fundamentally, there's no doubt that the majority are there because they really want to learn. They're just human, and another thing I learned, because I came out of industry, right? In industry, you have a job, 40 hours a week or whatever, and you concentrate on it all the time, right? So that you answer the emails right away. If you don't finish it today, you finish it tomorrow, that kind of thing. Well, in university, a student has 4 or 5 courses. They have clubs. They have sometimes many of them have on-campus jobs. So you don't really have them fully. You have them for the time windows of your course and some number of hours per week on your outside of classroom work. And so they're always triaging their time. They are always going like, well, I could spend an hour doing this exercise, or I could spend an hour preparing for my organic chemistry test because I want to be a doctor. And you can't blame them. So they're triaging their time. And you have to really, again, get the hang of that. Because I used to be easily frustrated as to why are they not as excited about this, or why are they not spending the amount of time I would spend on this. It's because there's just a lot going on. I was told a funny metaphor by a student years ago, which stuck with me and always gets a laugh from other students. The student told me, look, she said, like, look at my perspective. I feel like I'm the fire chief and I'm standing outside the fire station. I'm looking out over my town and there's like 4 buildings on fire. And I have to decide which one I'm going to put out first. And so there's a lot of triaging that goes on. And so because of that, you really have to take the time to explain why you're asking to do something, what the purpose is. It's not like you're defending yourself or spoon feeding them. It's just helpful to motivate them to do the thing. And it also challenges you to make sure the things you ask them to do are actually achieving a goal that's important enough to take the time. So you have to do that as you design the course. So where did this robotics course come from? Well, given all that I've said, you can imagine that I wanted to create something that would give students some kind of experience that was a little bit more like a real world software engineering job or software engineering project. I didn't know the first thing about robotics. I just was thinking about what would be an interesting thing that would be big, and we build an operating system, we build a consumer business. What do we do?
What year was this, Pito?
About 8 years ago. About 8 years ago. 7 or 8 years ago. And so I started, and this was like totally on my own nickel. I mean, this was not my job. I had no support for it, anything like that. I didn't have a course. But I started thinking about this more and more, and then I started reading about robotics, and I thought I got personally super fascinated with it, super interested in it, and I thought, okay, this is cool. Now we need something. We need a theme for this project. We need to know what it is I'm going to ask students to do. And so I came up with this thing called Campus Rover, which is I thought, oh, it's easy. I mean, this must be something that's been done 1,000 times before. We're just going to replicate what's been done before. This would be a robot that would drive around campus and take orders and deliver packages from one office to the other. It would go indoors and outdoors. It would even figure out how to go up an elevator. I mean, I had all these ideas that seemed like, because we watch TV, we see Star Wars, we see NASA and SpaceX or whatever. It seemed like it must be a solved problem. All I got to do is do a little research and figure it out. Well, like most of the things I've done, and maybe some of you can relate to this, maybe not, the best things I've ever done was because I just didn't know better. I didn't know that it's basically very difficult to do. And kind of that's true of my teaching, right? I got into teaching without knowing what the heck I was getting into. And I was sure this Campus Rover idea was a solved problem. I thought, all I got to do is dig around, read some papers, find some articles. Maybe there'll be a kit in Amazon I can use, whatever. Didn't turn out that way. But it was a good vision to build around and to inspire me to do a lot more work and allow me to inspire students around it. So that was the first premise of the course is, hey, students, we're going to get a group of people together and we're going to design and create this robot. And we know it's going to take more than one semester, so we're going to design it in a way that allows one group of students to pass their work to the next group, which was a very unusual thing to try to do. And it turns out to be difficult, as you can imagine. But that was the genesis. That's how it started. So let me just see really quickly if I can dig up. I think my search function is broken right now. Just really quick. Oh, it's not even here. Okay, forget that then. I wanted to show you the vision of Campus Rover, but I explained it in words pretty well. So there was no robotics course. I did not have a budget for robotics. None of the students in the department, as I mentioned, had any kind of electronics engineering or similar expertise. And we all know it's much too much to fit into one course anyway, much too much. But again, you know, innocence is bliss, so I just went for it. And the way I did it, what works out as a way to sort of get something going without having to design it and serve it up on a silver platter to administration, is we can all have independent studies. That's something that is within my scope of things to do. And so I created and publicized an independent study called Campus Rover, and I was able to get 6 students to join up, and we were going to learn together. So, what is it like to design a course? So I'm going to enlarge this so you can see it. Let me just do it this way. Let me go to here, and not that, but this thing here. So one of the things you do is you try to, and again, this is, I'm sorry about that. This is part of course design methodology, let's say. People talk about having learning objectives or, you know, skills to be achieved and so on. And there's just a lot of ways of doing this. And these days, there's something that has a lot of attention among academics, alternate grading systems or specs-based grading, to try to get away from grading, which is fundamentally very subjective, no matter how hard you try to make it not subjective, to distill it down to some essences. And in this case, this is what I've got. I'm going to reveal it to students tomorrow. And so these are the skills that I'm going to try to get them to learn in this class. And I'm going to have them demonstrate that they've learned it by programming assignments. But the programming assignments are going to be graded simply on whether or not a particular submission has demonstrated some or more of these skills. It's basically going to be, yep, clearly you understand how to use command vel. Clearly you know how to use pip. And if a student at the end of the term has a check mark next to each of these rows, there's a couple of other elements, they deserve an A. And so it's going to be, I'm going to make it more simple, less room for debate and argument is basically the idea. And you have to explain all this stuff, by the way, to students. I won't get into that, but this is the syllabus. So, I was talking about course design, right? So let me go back to where this picture I just showed you is this picture here, designing course. So the structure is always 13-week semesters and either 3 50-minute classes or 2 80-minute classes. That's what you've got to work with. Depending on how many students you're going to get, you're going to change your design of the course. Usually having to do with the logistics of running the course, running the classroom. How do you grade? How do they submit? How do you give them feedback? How many office hours? All those kinds of things. So if you have a class with 100 students, you approach it very differently than if you have 25, as you can imagine. So I've gone through all this. So the website that you have here has all this stuff in it. So you'll find, if you care to look, you know, the learning objectives, the homework assignments, how the assessment's going to work. In my case, I don't have slides. I have these things. This is just my own little, this software that I'm running, I wrote it. Oh, by the way, I should say, everything I'm showing here is open source. The content, the tools, anything. Anybody wants it, be welcome to it. I'm happy to give it to you. A lot of it is actually in GitHub and open repositories. So, so that's what it goes into designing a course. And this is how this course has evolved in this general structure over the last, whatever, 7, 8 years. So one big question was, what kind of robot? I mean, I didn't know anything. So I was Googling up forever. I was cold emailing people all over the world, asking about what robots they use and why, and so on and so forth. I remember emailing, it could have been with one of you guys, I don't know, but one of the, maybe it was Stack Overflow, or maybe it was the Ross Answers thing, where I asked, cheekily, like, they said, like, oh, you're learning Ross now and you're going to be teaching it in 3 months? Forget it. And I said, come on, it's just an API. How hard can that be? Well, I'm still
The best way
learning.
to learn is to teach.
Yeah, I'm still learning it, as you all well know. So, but I think it was a pretty good choice. I see other things from NVIDIA and other people creating their own operating systems. I always have to look at the cost as well. I can't afford a $2,000, let alone a $10,000 robot, right? No way. So,
Pito, we're going to
yeah.
need to wind this up in about 15 minutes, but keep going.
Okay. Good. I'm glad you said that. So, let me just see where I am. I'm going to talk. I can wrap it up in 15 minutes.
I'm interested in particular your campus robot and what its parts are.
Okay, this guy.
You're talking about your campus robot.
Yeah, the one, but that the campus rover was not ever built. Okay, because and let's put it this way, we're still building it. Okay, so by the way, this shows the lab at the beginning, which was just in an office. That's I had to and this is now the way it is now, so it's a lot bigger. So the evolution of our robots. I'm going to jump around a little bit. One of the things that people go like, why aren't you using ROS 2? Why aren't you using this or the other thing? Is it's a little bit different when you have a little fleet of robots. They all have to work. So you get a lot into cookie cutter, like, can I make them all the same? I got to tell everybody to run the software in a certain way and write instructions. So I end up, just like I said about Pascal and Algo and whatever, I have a lot of content that talks about ROS 1. And there's, at this point, with this many robots that I'm trying to keep alive, it's too dangerous and really not worth the trouble. The minute I'm done teaching and I'm doing my own robot, I'm sure I'll be running ROS 2. I never actually built Campus Rover. I mean, we thought about it, we drew about, but it exceeded my budget, it exceeded my knowledge, it exceeded what my students could do.
You haven't built it yet.
I have, yeah, exactly. That's how. In fact, if you look at my the Turtlebot 3s, which you can see here, I have a bunch of them. You can see them here. The problem with them is that they can't go outside. The wheels are too small. So that was the main motivation while we built this guy, which is the latest Brandbot, and this is the one that you can have the picture of. Oops, sorry, I want to make it bigger, but that didn't work out. Anyway, there it is. Actually, I have bigger pictures, but basically, this is a line. You guys all know Lino Robotics. I think you had the guy that designed that software.
Juan Miguel.
That's what I use for everything. So that's
the Brandbot is for Brandeis University, right?
There you go. Yeah, exactly.
Pretty sharp, huh?
Exactly. Let me jump to my little photo album here. Let's see. They're going to be a little bigger so you can see them better. There's what I just showed you. But let me show you a better picture of Brandbot. Here it is. So this is very nice, by the way. Clear plexiglass turns out to be very nice for teaching because you can easily show somebody how it's put together. But it's very.
What's the diameter of those wheels?
About 8 inches, maybe something like that. And then these are 2 casters, obviously. And we got the camera here. We got LEDs in the corners. We got a Raspberry Pi here. The IMU here, LED board here, and on the bottom we have a Teensy. It's pretty conventional, and a LiDAR obviously here.
So you're using Lino Robot for this?
I am, yeah.
Lino Robot 2?
No, 1. It's still ROS 1. It's still all ROS 1. So that's the robot. That's our latest model. We have 4 of them, and I'm psyched about these because they can go outside. But of course, when you go outside, hey, where's your Wi-Fi? Anyway, haven't solved that problem yet. Another thing I wanted to show you really briefly, which is kind of fun, is that we maybe I don't have it here. Oh yeah, we had a tour at Boston Dynamics recently, and this I think is it's one that they never commercialized, but this was about 2 or 3 months ago, and they showed us the old atlas, but they were not permitted to show us the new atlas. So that was pretty cool.
I see the old big dog back there too.
Yeah, there's a lot of old. Here we are. This is where they give us the demos. This is the group of people that went there with me.
That's the current big dog.
Yeah, exactly. Yep. And when I don't know if you've been there, but if you go there, in their working area, you see these rover, whatever they're called. I forget. They're not called rovers. Whatever they are, they're walking around. They're testing them. They're going in circles in a cage to make sure they don't crash, et cetera, et cetera. Quite cool. Let's see. So I think since we are kind of running lower on time, let me show you a couple of other things that I think are pretty interesting. This is interesting because this is something you may want to use. So it turned out to be a nightmare, as you all know, to get a group of 20 or 30 students to all get ROS running on their computers. Impossible. You got Macs that are held together with Scotch tape. You got things with like 3 bytes free or 1 gig of memory. We struggle with that a lot. We try to boot off of SSDs, all that. Well, the solution came in a cluster. So we have a cluster that's in an office somewhere, 4 computers, and every student gets their own account. So you end up with something like, and so whatever they're on, they have their own Linux environment in the browser. And similarly, we have a VS Code that runs the same way. And so I have the ability to spin up another node for a student coming in and give them that environment. Here's basically all the nodes in my little dashboard here. And I can create it in a moment. They instantly have all the software installed, all the homework assignments, all that stuff is installed. They don't have to do anything. Huge, huge, huge lifesaver. Make files to run it, etc. Thanks to a great teaching assistant from a few years ago who knew Kubernetes really well. So this is fantastic. If you ever have to provide a service like this to a group of people, it's definitely the way to go.
So when you give them the terminal session, is the ROS automatically installed on it, or did they go through all of that process?
No, it's all there. It's all there from the square one. It's all there. Catkin WS is there with the. Well, let me just show you real quick. I mean, basically, if I go,
it almost sounds like the construct of the AWS stuff.
I tried AWS robotics again a few years ago. It was, for me, very difficult to get it to do anything. And forget about trying. I mean, AWS is wonderful, I suppose, for a certain kind of customer, but I find the access control and the privileges and all those settings just very difficult to get working. And again, I'm always thinking about scale. Yeah, okay, that's fine if I can get it to work, but can I get it to work for 30 students? And that's a whole different problem. Here, they go in, they don't have to create a workspace, they don't have to install anything, it's all here. They can run whatever they want. And it's good to go. And so I have 37 of these that I just spun up a couple of days ago. So that's a really nice.
You didn't have any like latency issue?
Not especially, not especially. As you can see, I mean, you can try it if you want to have. I'll give you my password if you want to have fun. I'm going to give you the URL. You can play with it.
No, I'm just saying it's because like the sensor data should go, and then the computation, then the motor data come back.
No, but the robot has its Pi on it, so it's doing all that stuff, right? It's happening on the robot, and so the sensor data actually has to go through a VPN, so there's definitely a lag there. I
So
got the
what
right
are you
button.
running, like Slam Toolbox and the nav stack and so forth on your computer? on your
Yeah, I'm running all that on this cluster. Yeah.
workstation? Yeah,
And there's almost nothing running on the robot itself, just the minimal,
just the
grid.
package.
Yeah, exactly.
And do you
But
have the camera stuff? So like the high side, high
yeah,
bandwidth?
yeah, it's so if I go back here and
So are the robots running the Lino robot package?
yeah, they are exactly. Yeah, exactly. So it's pretty fast, as you can see. Let's give it gazebo to make it even more challenging.
So, okay, are you actually running multiple ROS robots? Are you dealing with like namespaces and stuff?
Yeah, we haven't talked about that. Yes, I have to figure that out. I'm not dealing with namespaces. What I'm doing is every robot has ROS4 on it. So I have every robot on its Pi running ROS4. So they don't know about each other.
It seems like unless you had namespaces in there, that would get they would
No,
all be
because
running the same command
No,
velocity.
they can't see each other. Each robot has its own ROS4 running on the Raspberry Pi. They literally can't see each other.
This is ROS1, right?
It's ROS1, yeah.
No,
I get it. So ROS1's going through the master. You couldn't really do that with ROS2 without namespaces, right?
I don't know. I hope you can,
I think
because
so.
namespaces are a bit
Well,
of a nightmare.
it's node to node with ROS2 versus going through the master.
Well, that's another reason I'm not on ROS2 yet.
Or you can limit ROS2 to a single machine, I believe. It won't go outside.
You use namespaces.
It's an interesting question how you would do this with ROS2 if this scheme would work. But with ROS1, it works great.
Stay on stay with the mailing list, Pito. We'll figure it out.
Yeah. Let's see what else. One other resource that's kind of cool that we built over the years is the lab notebook, which I'll click on here. And this is a massive database of content. Like I have a massive knowledge base here, as you can go here and let me open up the window a little bit more so you can see it. So we have just a ton of things like advanced, help me troubleshoot weird build problems. Where does ROS CD go? Why does ROS CD go wrong? Publish commands, etc. This is just collected by students. I have them. I mean, I write a lot of them myself, but I have them as part of the final assignments. They are required to submit 2 new entries in the notebook, something they learned, something that was tricky to figure out. And so that's how this thing is built up over the years. Here's we actually have detailed instructions on building the brand bot that we built so we can build more of them. This is all in the lab notebook. And then you can click on that and find it as well. Let's see, what else? Let me go back to my main thread here. Okay. I wanted to build institutional memory. So I wanted to have some way, and I mentioned that before with the campus rover, I wanted to have some way to have the knowledge acquired by one group of students or the accomplishments of one group of students to be able to be carried forward to the next group. What about AI, you're wondering? What AI and LLMs have really freaked out teachers, and how do you handle that? I'm trying to make this bigger so you can see this. So you actually have to come up with an LLM policy, and this is mine. And basically, I'm telling them that, listen, we all use ChatGPT, etc., and you'd be crazy if you didn't, because it's like working with one hand tied behind your back. But remember that just like Google, YouTube, and Stack Overflow can give you incorrect answers, you can't just hope to type in what you saw. You have to understand the code. And so I say what is okay. And again, this is when you're teaching, you have to go through this kind of like analysis, is to use AI tools as reminders for APIs, for Python syntax, for shell commands, ask what an error message means, and even to generate a code snippet so you can see how it works. It's not okay to submit as homework or a programming assignment anything that was not written by you. Ooh, very important typo here. Anything that was not written by you that you don't understand, that was taken verbatim from an AI tool's output or any other place. And if you're not sure, ask a TA. So this has been, a topic of great hand-wringing in the university because asking a student to do a homework assignment at home or not in the classroom, not live, you have to accommodate the reality that they're going to use an LLM, and you have to figure out ways to still be able to assess them in a fair way. So what I'm doing for my programming assignments is I ask students to not only give us the code, which we will try to run, and also check for plagiarism, but also record a 2-minute video in which they show and explain how it works. And the premise is that it's going to be very difficult for somebody to fake that. And that's how we're going to try to overcome the issue of having people use LLMs to do their work for them. So, final slide. What can be improved? I can't escape the feeling that there's still time wasted with students troubleshooting stupid things. You can't create a total padded cell. You want them to experience what it takes to troubleshoot something. It can't be just rolling off a log. But it kills me when I hear somebody's been up for 6 hours because of something I could solve in 6 seconds, like a typo in an IP address or something like that. So that's, I don't have an answer, but that's something that bothers me. There's also too much fact in the course. I just try to cover too much, but I try to give them enough that they can build a working ROS robot. And so as a result of that, some of it is a little superficial. I wish I had more time for more of the mathematics and more of the electronic part of it and the signals part of stuff. So some of the learning is superficial, but it's only one course. I'm really proud of the course in the end. What I'm happy with, I'm really proud of the course. I think, well, it's fun to teach. I think they learn a lot. They work very, very hard. And when they come out, I feel confident to say that they've learned how the basics of an autonomous robot. So that's kind of the story. Before I let you go, I want to give you a quick tour of, let me take this out of the way, whoops, of some of the projects that they did. Because I said before that they're very, let's see if I can do this. That's not the right display. Go like that, make it smaller again, and just double click on this. So these are PDFs. This is their posters. So these students did a autopilot that would respond to traffic lights and make the car stop and go. And there's their setup there. Here's their little icons and a little bit of their camera. Pick a different one. This is a nutty one. I told you people come up with crazy ideas, right? And you have to like decide whether you're going to let them do it or not. This student wanted to use a robot arm to type on a physical keyboard. And it's the Typinator, and they built it. It was extremely rough. It barely worked, but it was an interesting, fearless thing to try to do, which I never in a million years would try to do. Here's another project. Oops, sorry. Here we go. This is a fun one. Home surveillance. This student made a what happened here? Okay. Let's do this one. Too many windows. What's that doing there? Again.
Technology is great when it works.
I know, that's right. Here we go. So this one made a, you can see it, and just make it a little bigger. So pretty elaborate. He made a maze. He had 4 Turtlebot 3s running around it. He made a map, and the idea was that when it detected an intruder in any of the areas, all the other robots would come over to help. You know, and they do a good job explaining these things and thinking about them. And then we have like an open house when people come around and the students present what they did. So anyway, so basically I'm happy with the course. I'm proud of it. I think I wish I had another faculty member to help teach this material. It wasn't just me. I have the most students I've ever had in this coming semester, so that's going to be a challenge, 37 students. So I have to have 2 separate lab meetings because they don't all fit in the lab. But anyway, that's my story. I'm happy to take any other questions anybody has.
Thank you very much, Pito.
Thank you.
Hi there, this is Steve. You mentioned software that you guys created. And so of course we see a lot of the ROS, et cetera. Were you talking about presentation software, or what other software do you guys have?
Well, this is also the software that I use to build these websites is available. So this is just, it's not for websites, it's for a course. So it's basically got all the date handling for different classes. And you know this poster, it's kind of cute. We do this not because it's easy, but because we thought it was going to be easy. And then you know this quote, obviously. But that's a piece of software. Course, I call it Course Gen. It's something I wrote myself. And I use it in all my classes. It's a huge time saver, but it's kind of particular. I would say the content, a lot of the content, a lot of explanations, a lot of the FAQs may be of use to somebody. Certainly, if you're going to teach a course, you can start with this and modify it. Basically the architecture of the cluster, the make files that go with it, all the techniques, the documentation, that's all available. And then all the student projects, but you know, your mileage may vary. I mean, there's a GitHub repo called Campus Rover. It's an organization called Campus Rover, I should say. And you'll find the majority of our software here, all student projects, you know, like just a ton. It's, you know, truly your mileage may vary. This one was a student project where they wanted to make it, I think, throw a ball using the arm or something like that. So
do you know right off what motor and wheel you're using on the Brandbot?
I don't know right off, but I know where to find it. We have, let me just show here. Here's what this thing, get this out. Oh, I see, okay. Change it to my account, to my Brandeis account. And go to start. And go to Brandbot. And go to the materials.
Drivetrain.
There we go. There's the bill of materials. What are we looking for? The wheel?
Motor and wheels.
The motor? Okay, motor. Motor assembly, motor. Vehicle frame. That's not it. Drivetrain. Motor, here it is. Polulu 4693. Oh no, wait a minute. Yeah, that's it. That's it. That one. This one. For what it's worth. And then the wheel is wheels are these guys. Here.
Is that Pololu also?
Yeah, Pololu also. Yep.
Right. Any other questions for Pito?
what's the concept that students tend to have the most difficulty with?
Probably the totally asynchronous nature of the logic you write. You know, the main loop, the way callbacks work, the way you have to divide up your algorithm into steps, somehow preserving state from step to step, those kinds of things. It's very, very different from what they've done before. And I think the other concept is the fact that robots are not, they're noisy, things are not reproducible necessarily. Things don't work exactly the way the book says they're supposed to work. You know, on one robot, for some reason, we mounted the LiDAR backwards and all the degrees are wrong. And how can that be, you know, and that kind of stuff. So the fact that they're not just a piece of software, not a Python program, I think that's hard for you to get around. And so they end up, you know, but the funny thing is that where I, and maybe you all, as a software developer with experience, would go like, I'm not going to put up with this. I mean, I'm going to find out what's going on instead of trying 100 different color combinations to see which one of them work with the tape on the floor. I mean, it's all, you know, I would go like, let's write a program to see what the right color is. But they go like, okay, let's see, 255, 3, 2, that didn't work. Let me try this. And so there's a certain very lack of maturity, I guess, in dealing with problems. But I would say that the asynchronous nature of the algorithms and the fact that things are noisy and not reproducible are the biggest ones.
All right, thank you very much. Any other questions? One last question, maybe? Pito, I want to thank you very much for doing this presentation. It was awesome. Also, your course material, I'll post it to the mailing list. It looks like it's going to be very useful.
I want to thank you all also very much again for giving me this chance, and also for being a great group of people that I have the pleasure to work with, and I hope that we will keep on seeing each other online. Unfortunately, it's way past my bedtime now. So
good luck with your students tomorrow.
I know. Okay.
All right, guys. Next month.
Thank you so much.
All right. Take care.
Next month is our challenge month, so everybody has a presentation to give. Get to work in your robot, and we'll be bugging you all month long. Thank you very much for coming out. And this concludes this meeting in the Homebrew Robotics Club. Thank you very much. Bye-bye.
I love that. Hammer. Excellent.
Thank you, Pito. We'll see you later. Thank you. Thank you, Ralph. Thank you, Thomas. Ed Martini.
Night,
Good to
Cam.
see you. All right. We had some fun.
Should I stop the recording or we got any more?
Go ahead and stop the recording. This is random access. We're just hanging out in the parking lot now.
Just waiting for security to kick us out.
We're just waiting on security to kick us out. Hey, Rohan, how you doing?